Today we're going to talk about areas of sectors and circles. And the most important thing that you need to do is every single one of these problems, I want you to write the area formula down. Because you're going to have a lot of formulas that are going to be coming up, and you want to have those memorized. And that's the easiest way to memorize, is to write them over and over and over again. So in the middle of your box, where it says area of a circle, A equals, I want you to write pi r squared. Very center of your notes. So the area of a circle is pi times the radius squared. If you know the radius, you square it, you multiply it by pi using your pi button on your calculator, you've got the area of a circle. Now I need to make a distinction here. Sometimes your book will ask you for the exact value. If they want the exact value, that means leave it in terms of pi. So if my radius was 5, I would square 5 and get 25, and I would just write that as 25 pi. I would not multiply the pi out. That's the exact value. When we multiply pi in, then we get an approximation. Does that make sense to everyone? Okay, so if they ask us to give it to 2 decimal places, they want the approximation. If they ask us for the actual accurate answer, okay, then they want you to give it to us in terms of pi. Yes? No. We want to apply the area of a circle formula. So the very first thing I need to see on your paper, on your assignments, on your quizzes, on your tests, is that you write the formula down. Okay, example 1 says to find the area of a circle if the radius is 6.5 inches. Okay, 8.5 inches, my fault. Okay, so I want you to write the formula down. What's the formula for the area of a circle? Pi r squared. So write A equals pi r squared. What did they give us? 8.5 is the radius, so we're going to plug that in for r. So on your paper, I will see A equals pi r squared. And then I will see A equals, and if you want to put your 8.5 first, that's okay. If you want to put it second, that's okay. But I will see that you've plugged that number in for your radius. Yep, then unless they tell us to give the exact value, we go ahead and take the 8.5 and square it, and take that times pi, and use the pi button on your calculator, not an approximation of 3.14. So did everyone get 226.98? And what's my unit going to be? Inches squared, because we took inches times inches to get inches squared. You don't have to, well, if you're going to square 8.5, so if you recognize that all of 8.5 is being squared, you're fine. It's up to you. I just abbreviate it with IN instead. Okay? So if they wanted the exact value, it would have been 72.25 pi inches squared. This is the approximation because we multiplied it by pi and rounded. Okay? All right. Second part of this example. Now we want to find the diameter of a circle that has an area of 153.94 square feet. So what's our first step? Write out the equation. A equals pi r squared. Okay? Now plug it in. What value did they give us? 153.94 is our area, is our answer. We're wanting to set that equal to pi r squared. I would do it the opposite way. Good. So now we want to find the r, and pi is being taken times r. So how do we get rid of the pi? Divide. We divide both sides by pi. And 153 divide 0.94 divided by pi is 49. So if 49 is equal to r squared, what will r be? Good. How did you find that? You square rooted it. The opposite of squaring is square root. We square root 49. We get r is equal to 7. Are we finished? No, because what did they ask for? Diameter. If they ask for the diameter and we have the radius, what do we do to the radius? Times it by 2. So our diameter is 14. And what's our unit? Just plain feet. And if you want to abbreviate it as FT, that's okay. If you want to write feet, that's fine too. We want to make sure we're watching for our units. It's good practice. Okay? What questions do you have on these first two? The 72.25 is just 8.5 squared. Okay? So this is the equivalent of that. And then when I multiplied that with pi, I ended up with my final answer. So if they ask for an exact value, they want this. If they ask for it to 2 decimal places, they want this. Okay? All I did was took 8.5 times 8.5 to get the 72.25, and it still had to be multiplied by pi. Okay? Other questions you have on this slide? Okay? It depends on which the book is asking for. Okay? This is called the exact value because there was no rounding. 72.25 terminated, it's complete, and it's being taken times pi, which is that irrational number that keeps on going. But if they don't care and they don't specify exact, you can go ahead and multiply pi in using your pi button on your calculator. And this is really going to be an approximation because pi never ends and never terminates, and we rounded. Okay? All right. Next problem deals with population density. So population density is used all the time in city planning because they want to know, do we have enough fire services? Do we have enough police officers? Do we have enough schools, enough resources for particular areas based on the population? Okay, so we're going to look at the extreme, which is Manhattan Island in New York City. It is the most dense per population of anywhere in the US. Okay? When you're finding population density, you're looking for the number of people divided by the area of land that those people occupy. So in this first example, they tell us that about 1.626 million people live in the 22.82 square miles of Manhattan Island in New York. We want to find the population density in people per square mile. So for any given square mile in Manhattan, how many people live there? Okay. So we're looking for population density. What are we going to do with these numbers? Divide them. So what number is going on top? Okay. So 1.626 million people. And we're dividing it by 22.82. Very good. We're going to have to add some zeros, aren't we? Because if we just plug this in as 1.626 divided by 22.82, we're going to get a decimal that doesn't make a lot of sense, right? Okay. So, great question. How many zeros are there in a million? 6. So what is this going to look like as with the zeros added in? So it will be 1,000,000 what? 626,000 people, right? We abbreviate this because it's easier to do that on a website or in a book or in a newspaper, okay? So 1,626,000 people divided by 22.82 square feet in that island, square miles, thank you. What do we get when we divide it out? Okay. So 71,000, what was it? Okay, that's people per square mile. So how big is a square mile? That's an area that's 1 mile by 1 mile. Okay? So when you think of 72nd to 84th, that's a mile. And then if you think of 370 to Portal, that's probably about a mile. So there's 71,000 people in that 1 mile square mile block. I'm trying to think. Cornhusker to, yeah. So your major stoplights are usually about a half a mile, but 84th to 72nd is 1 mile. Okay. Now let's look at Omaha. Population density of Omaha is much, much less, right? We only have 3,247 people per square mile. Not nearly as densely populated, right? So we're trying to figure out how many people are living in the city of Omaha based on the fact that from the city center, there is a circular area with a radius of 6.5 miles. So what do we have to do? Okay. So we have 3,247 people. That's our population density. And that's equal to the number of people, we don't know how many people there are, divided by the area. How do we find the area of Omaha? A equals pi r squared. Our radius is 6.5. So we're going to take pi times 6.5 squared. So you're going to plug this into your calculator. 6.5 squared times pi. And you get 132.73 if you round it. We don't want to round it. We want to keep it in our calculator. So if x is being divided by 132.73, what do we do to clear that dividing by 172? Multiply. Quiet. And you too. Focus, please. Okay. So we multiply and we get, we're taking our 132.73, which is already in our calculator, and we're multiplying it by 3,247. So x is going to be equal to 430,982. Put your commas in, and how many people is that? Okay, so roughly 431,000 people. Okay. Questions on this slide? Okay. This next slide is very similar to what we did yesterday. Yesterday we were looking for an arc length. And we didn't have the whole circumference that we wanted. We just wanted a portion of that circumference. So yesterday we took the measure of the sector, divided by 360 times our circumference, and got our answer. Today we want to know what is the area of the sector that's formed by this angle. And we want actually two areas of two sectors. So let's start with the orange figure and find the area of that sector. So how would we do it? Area equals pi r squared. 135. No. No. It's going to be pi times 15 squared if I wanted the whole circle, right? But I don't have the whole circle. What portion of this circle is this orange area? 135 out of how many degrees in a whole circle? 360. Same thing we did yesterday, only we're using the area formula instead of the circumference formula. Because yesterday we wanted to know how long was this, just that piece. Now we want to know how much area does it occupy. Okay? No major stretch from yesterday. So you decide how you want to plug this into your calculator. You can take 135 out of 360, so divide first, then times pi, then times 15 squared. Or you can start with your 15 squared, take it times pi, take it times 135 divided by 360. You'll get the same answer both ways. 135 divided by 360 times pi times 15 squared. Your calculator should know to do the 15 squared before it does everything else. And what do we get? And if we keep going with 2 decimal places, what will my unit be? My label? Right, and so if it's 265.07, how many, what, okay. Yeah, and we're just going to 2 decimal places, so we're good. Yep, and we're not doubling it, we're squaring it this time. And so 265.07 what? So if it was in centimeters and we took it times centimeters again, we get centimeters squared. That found the area of the orange sector. Liam, how are we going to find the area of the blue sector? We want the areas of the two sectors formed. Okay. So if we have a whole circle is 360 degrees and 135 is the orange, how much is left for the rest of it? Yes, 365 minus that 135, 360 minus the 135 gets us what? Megan, what's 360 minus 135? Okay, so 225 is this major arc. And so we're going to plug that into our area formula now. We want to take 225 out of 360 times pi times our radius squared. This is the only way that I know. This time we're using area, not circumference. So yesterday we were using circumference, 2 pi r, but this time we're using area, which is pi r squared. We have to take radius times itself. times the pi. Right, right, which is squaring it. Okay. You bet. Okay, so 15 times 15 is 225. We're taking 225 times pi times the 225 over 360. Okay. Works the same way. We'll get it no matter which way we go. Okay. So we can round it to 2 decimal places. So 441.79. And again, we're finding area, so centimeters squared. Okay. Are we good? All right, next example is going to ask us to go backwards. We're going to have the area of a sector, and we want to find the area of the whole circle. So they've given us the orange area, the area of the orange figure, and we want to know what's the area of the whole circle. How do we find the area of a circle? Pi r squared, right? So if we want to find the area of a sector, we were taking the 135 out of 360 times that whole circle, right? Okay, so 135 out of 360 times the area of our whole circle is equal to this 48 square feet. Okay? You could also find, well, we wouldn't know it though, we don't know the radius. So you could work your way backward, find the radius, and then use that to find the area of the whole circle. Or we can take a shortcut and we can say, let's take 135 out of 360 times the area of the whole circle, and that would be the area of our orange piece. So what do we do to get the area by itself if it's being multiplied by 135 over 360? Divide, but dividing by a fraction is the same as multiplying by its reciprocal. Okay? So we simply flip it over. Instead of multiplying or dividing by 135 out of 360, we're multiplying by 360 over 135. We can't divide it out and then multiply because that would be multiplying both sides by the same number. Okay, so we have to multiply by its reciprocal. So these guys cancel, and we get plain old area of our circle. So when we're finished, we'll end up with area equals 48 times this 360 over 135. So 48 times 360 divided by 135 is 128. And our area is in square feet again. .48 times 360 divided by 135. Yep, we just flipped them in order to get the area by itself times the other side. Okay. Give me 1 second. Okay. All right, we got one last question real quick. Okay, one last example. So this time we have a field. And this field is made up into it look like a heart. So one portion of it is a square. And the other two parts are what? Half circles, semicircles. Okay? So if we want to find the area of that whole figure, what are we going to do? I don't think we need to use SOHCAHTOA this time. We want to find the area. Okay? So we're going to add a square and a circle, right? Okay? Yes, sir. Good. Okay. Good. So think about it as a plan. We're going to find the area of a square plus the area of one full circle. The area of our square, we can either take length times width or we can take side times side. Okay? So length times width or side times side. How long is our square? 8. So if we have 8 times 8, okay, we'll get 64. Now we need to add one full circle because we have 2 semicircles. Okay? And as you've noticed, they gave us a diameter. So our radius of our circle is 4. So to find the area of that circle, half the diameter. So we're going to take pi times our radius squared. So r squared is 16, and we'll multiply it by our pi. We're going to end up doing what to both of them? Adding them. Okay? So if they want the exact value, this is your answer. But if they want you to multiply it out, when we take 64 plus 16 pi, we get 114.27. What's our unit? Meters squared. Okay? Are we good? Okay. Back side of your sheet is your assignment for today. Show your work. I need to see equations on every single one of them. 16 times the pi first, then add. Yep, multiply first.